More than 40,000 Amish families in Lancaster County draw water from underground cisterns that have functioned for 80 to 150 years. No pump, no electricity, no replacement. A conventional well system costs up to $40,000 over its lifetime. A gravity-fed cistern costs under $2,500. This same engineering sustained entire civilizations for centuries. The question isn't whether it works. It is how it disappeared from modern building codes, classrooms, and contractor training. In the Jordanian desert, Petra's survival depended on cisterns carved deep into sandstone. Nabatean engineers lined these reservoirs with lime plaster mixed with volcanic ash, creating a seal that still holds after 2 millennia. Some cisterns held up to 30,000 cubic meters, with the city's total storage nearing 150,000 cubic meters. Access shafts allowed for cleaning, and Byzantine inscriptions record the ritual of renewing the plaster, showing maintenance was built into the system from the start. North in Istanbul, the Basilica Cistern lies beneath the city's busy streets, a silent chamber built in 532 CE for Emperor Justinian. Spanning over 14,000 square meters, it could store 80,000 cubic meters of water. 336 marble columns, many salvaged from older temples, support its vast ceiling. The waterproofing, double layers of mortar with crushed marble and pozzolanic ash, has withstood centuries, as confirmed by modern core samples. Fed by the Valens aqueduct, the cistern could refill in less than a day, supplying the palace and its neighbors through siege and drought. In Jerusalem, Hezekiah's tunnel runs 533 meters through bedrock, carved in the 8th century BCE. Its gradient, just 0.06%, guides water by gravity alone, a feat of precision engineering. Mortar fragments date the tunnel to King Hezekiah's reign. Inspection shafts every 30 meters allowed ancient workers to keep water flowing, and today, flow studies show the tunnel still works as intended. Across these sites, 3 constants appear: lime ash linings, careful control of elevation, and gravity-fed systems. Their endurance is written in stone, proof that passive design and routine care can outlast centuries. In Lancaster County, Pennsylvania, more than 40,000 Amish live without the modern convenience of municipal water lines or electric pumps. Their solution is neither new nor experimental. Across thousands of farms, underground cisterns, some built by hand over a century ago, still provide daily water for households of 8 to 12 people. These systems operate year-round, drawing on gravity alone. No pumps, no wiring, no monthly bills. Family records and farm journals document service lives stretching from 80 to 150 years, with some cisterns still in use by the great-great-grandchildren of the original builders. Maintenance, when it happens, is simple: a periodic cleaning, an occasional patch of lime mortar, and the water keeps flowing. Routine use is measured not in gallons per minute, but in generations. A typical Amish family draws 5 to 8 gallons per person each day, enough for cooking, laundry, and livestock, without the need for electricity or pressure tanks. This approach scales quietly. From single homes to entire communities, the same gravity-fed logic supplies water through droughts and blackouts alike. Some families keep detailed logs, noting repairs, sediment removal, and annual water use. These records show a pattern of reliability that modern plastic tanks and electric pumps rarely match. The Amish cistern is not a relic. It is a living system, maintained and trusted by people who depend on it for every aspect of daily life. Its continued use in Lancaster County offers a rare, working example of pre-industrial engineering that delivers both resilience and independence, qualities often missing from modern infrastructure. The evidence is in the numbers, the logs, and the quiet persistence of a technology built to last. Every Amish cistern in Lancaster County relies on the same 3-part design. At its core is the underground vault, a chamber sized to hold between 5,000 and 15,000 gallons, buried below the frost line to keep water cool in summer and unfrozen in winter. Builders use poured concrete, brick, or stone, sealing every seam with a lime-based mortar that resists water and lasts for decades. The vault's capacity is not arbitrary. For a family of 10, even at 8 gallons per person per day, a 10,000-gallon chamber can supply water for over a month of dry weather without refilling. Collection begins at the roof. Metal sheeting channels rain through gutters into a first flush diverter. A simple standpipe that discards the initial runoff, flushing away dust and debris before clean water enters the cistern. The efficiency of this catchment is high. A 1,000 square foot roof collects roughly 600 gallons per inch of rainfall, and with annual precipitation averaging 42 inches in Lancaster County, a well-maintained system can refill several times per year. Delivery depends on gravity. Each foot of elevation drop from the cistern to the tap generates about 0.43 pounds per square inch of water pressure. A 15-foot difference, easily achieved by siting the vault uphill from the house, yields over 6 pounds per square inch, enough to run faucets, fill troughs, and irrigate gardens without a pump. The entire system works without electricity, relying on nothing but slope, storage, and the natural flow of water. A side-by-side look at the numbers reveals the stakes for any homeowner. Building a gravity-fed cistern system in the Amish tradition typically costs between $800 and $2,500 in materials. That includes the underground vault, lime-based mortar, metal roofing, and basic piping. No pumps, no wiring, no pressure tanks. Once installed, the system operates for 80 to 150 years, with only occasional cleaning and minor repairs. Over a 50-year window, the total outlay for an Amish-style cistern rarely exceeds $3,000. Compare that to the standard well and pump setup. Drilling a private well, installing an electric pump, and adding a pressure tank often runs $15,000 to $40,000 upfront. Even a single 5,000-gallon plastic tank costs $3,500 to $6,000, and most will need replacing at least once in 25 years. Factor in pump replacements, pressure tank failures, and annual electricity bills, and the lifetime cost climbs past $45,000. The difference, over $42,000, reflects more than just hardware. It is the price of dependence on short-lived materials, recurring service calls, and the steady pull of utility bills. For families weighing long-term security against short-term convenience, the arithmetic is blunt. The Amish cistern is not just a relic, it is a working alternative that leaves a permanent gap in the ledger. Colorado's long prohibition on residential rainwater harvesting stood for decades, written into statute as a blanket prohibition. Until 2016, homeowners collecting runoff faced fines, even if the water was used only for gardens. The law changed with House Bill 181225, signed in May 2016, allowing up to 110 gallons per household, a fraction of what Amish cisterns hold. The new rule took effect on January 1, 2017, but the storage cap kept large-scale, gravity-fed systems out of reach for most residents. Elsewhere, building codes act as a second barrier. The International Plumbing Code, Section 601.2, defines an approved water supply as a municipal connection, a permitted well, or by special exception, a rainwater system that passes local inspection. Most jurisdictions default to the first two options. Without explicit amendments, inspectors rarely approve cisterns, citing the code's list of potable materials and liability requirements. Concrete, stone, and lime mortar, materials proven over centuries, are often left off the list, while polymer-lined tanks certified to industry standards pass without question. Federal procurement rules reinforce this pattern. A 2022 Government Accountability Office report found that USDA contracts for rural water projects routinely specify polymer liners, favoring established manufacturers. Concrete and stone cisterns, though durable and low cost, are excluded by default. The result is a market shaped by code language and procurement templates, not by evidence of longevity or performance. These rules, written to ensure safety and uniformity, end up narrowing the range of solutions and sidelining systems that have served reliably for generations. In technical manuals and design bulletins, the expected lifespan for a modern lined pond or storage tank is set at 40 to 60 years. The United States Department of Agriculture's Natural Resources Conservation Service codifies this in its engineering standards, and state plumbing codes reference similar benchmarks for approved water storage. Yet the knowledge of how to build a gravity-fed cistern, once passed down through apprenticeships and vocational classes, has faded from formal education. Reviews of trade school curricula show that by the late 1960s, cistern construction was largely omitted, replaced by coursework on pumps, pressure tanks, and plastic liners. With each revision, the practical details of passive systems receded, leaving engineers and inspectors trained to expect short service lives and to specify only factory-certified materials. As institutional memory narrowed, the task of rediscovering resilient water storage fell to laypeople willing to look beyond the standard checklist. Starting a cistern project begins with a careful site survey. Walk the property to find the highest practical point. Every foot of elevation between the cistern and the tap adds water pressure, 0.43 pounds per square inch per foot. Check that runoff from roofs can be cleanly diverted, and confirm that the ground is stable for excavation. Before breaking ground, identify any nearby septic systems or chemical storage to avoid contamination. Plan for access. A removable cover and a safe ladder make future cleaning possible. Set a maintenance schedule. Sediment should be removed every 5 to 10 years, and the lime mortar lining inspected for cracks. With these steps in place, a cistern can deliver reliable water for decades with minimal intervention. Today, Amish cisterns prove that durable, zero-electricity water supply is not obsolete. Only the knowledge is. As codes and markets favor short-lived tanks, the cost of forgetting grows. The real challenge now is to find your highest ground, measure the drop, and ask what is truly holding us back. What is your elevation?